Here's my outline. Just goes over every slide. Introduction and history of drones. Drone technology began as a military and recreational device, but has increased its use in the world over the last decade, especially in construction. Drones have increased safety, cost savings, and improved efficiency. In the 2010s, drones began their life in construction as aerial surveying tools. They allow for a safer, cheaper, and more efficient way for surveyors to do their job. Drone technology advances daily with things such as BIM, Building Information Modeling, and GIS, Geographical Information System, which allows construction professionals to convert raw data into usable models. The future of drone and construction is bright. With things such as AI and 3D mapping, it will only become a more integral part of the construction process. The real purpose and application of drones in construction are three different things: construction infrastructure, surveying, and safety. On the construction infrastructure side, it's used for volume measurements, 3D models of sites, and tracking progress, as well as a little bit of QC. For surveying usage, it could be used for land surveying, topographical maps, and land management and development. And as for safety, it allows for real-time updates on safety hazards, less need for site visitation, and can monitor hard-to-reach risky areas. So what this basically means is like a drone can fly over multiple times a day, and it can go to every little small spot on the site, as well as it allows for people to remotely look at these safety updates. So it's less risky. There's not as many people visiting the site or walking the site as often. Fundamentals of drones. With drones in the construction site are safer and more efficient with their time and money. Drones offer ability of real-time updates, more precise land and topographical surveying, 3D models, and much more. Drones have a large impact on construction thus far and will only continue to improve as technology advances. There's a few different types of drones. We're going to go over them now. Multi-rotor drones, hobbyist drone. This is more of a hobbyist drone. As AI improves, as does the image stability, it's user-friendly, 48 rotors, limited battery life, not optimal for BIM or 3D imaging, 30-minute flight time. So this is just pretty much your recreational drones. Helicopter drone has a one main rotor. It's going to have a higher flight time. It's not as user-friendly, but it'll be a little bit steadier than your multi-rotor, for example. A little less battery life, and it will allow for less turbulence since there isn't as many rotors. Fixed-wing hybrids. So this is a drone that can fly in the vertical and horizontal positions, not just horizontal as just a wing drone does. The same benefits as a fixed wing, but it's going to be more stable, and it's going to have more maneuverability because it has that vertical movement. So it just means it can just go straight up and down. As for like just a fixed wing, it can only fly like an airplane. This is going to be one of your least common drone types, and being that with that said, it's going to be the most expensive, and it's not going to be very user friendly. And it's oftentimes used for like package deliveries for like Amazon or whichever company wants to do that. And this is the fixed wing drone. It flies like a conventional aircraft, so like just any commercial airline almost. It just creates lift, and that's how it stays in the air. It cannot remain stationary like a fixed wing hybrid or a multi-rotor drone. And it needs preset flight points, so if you use one of these for surveying or a 3D mapping, you would need to set your points of flight before you fly the drone. Probably has the longest flight time out of all of them, with 2 to 24 hours of flight time. It can be either electric or petrol, so you can either run off gas or maybe diesel. I didn't do the research on diesel, but it might. Highly skilled pilots required, so you're going to definitely need your pilot's license for this, like a drone pilot's license, so some kind of education will be needed to fly it. And it's best for aerial surveillance, so for like military or private industry uses. So the cost of drones overall can vary depending on the aspects of the job and the specific drone used. You can either contract out drone services or invest in a drone, which with Trump's new tax cuts, well, not new anymore, but when he was in office, allow these drones to be written off within a year. So it makes it pretty profitable for your company. With the possibility of write-offs and contracting taxing on bids, I recommend investing in a drone. If you invest in a drone, here are a few different options. The 2 to 500 is pretty much your recreational multi-rotor drones that I began with. 500 to 1500 will give you a drone that's a little bit longer battery life and a little bit more capabilities in terms of 3D rendering and a little bit increased sensor range. 15 to 2500, this price range will have more durable device with camera controls and high resolution, as well as the same benefits as your 5 to 1500 and 2 to 500. And 2500 to 6000 is the most recommended price range. These drones usually offer 4K resolution, software that helps you compare topographical data with 3D renderings, and remotely basically endless battery life. A little bit more on the safety aspect of drones is project monitoring. So drones allow for the project team to view hard to see places on the site much easier and quicker. They also allow for speedier progress reports and a better aerial visual of potential problems that could cause setbacks on the project. On-site inspections. Site inspections can be difficult, drawn-out processes, but it is necessary. Aerial photos and videos from drones help fix the problems associated with traditional methods. Drones allow for inspections to view hard-to-reach unsafe places from the comfort of an office or a remote office. By using drones, you're improving the safety of inspectors themselves and the overall site because they can look at a much larger and clearer image, and it's much more in depth in terms of visiting every small nook and cranny on the site. And then also, like I mentioned earlier, people don't have to visit the site to review the safety. Communication. Through drone technology, the progress and state of the site is more quickly available to the project teams. It also saves on the risk of having the project team to make physical trips to the work site, like I just said. All right, for Texas use, Texas is a notorious hot state. Therefore, drones can help a project team view from the comfort of an air-conditioned office and not having to constantly go in the heat and risk heat stroke and whatnot. Summaries and conclusions. Drones have improved the safety, cost, and efficiency of construction. It will continue to advance over time and aid in surveying, BIM, and topographical mapping of sites. The ability to view progress online and it will reduce cost of traveling and safety risk of employees on site. It is fiscally responsible to buy a drone over contracting one out due to the tax write-offs available to you. Here's my references. Test your knowledge. Number 1, primary benefit of using drones in construction, specifically in Texas. You don't have to deal with the heat. You can go out and view the site with a drone and look at site progress without having to deal with the Texas heat in the summer. What is the average flight time of a multi-rotor drone? So that's our recreational drones, our cheapest option, the $500 to $1,000 drone. The average flight time of this multi-rotor drone is around 30 minutes, maybe an hour. So last and final, test your knowledge. Which drone is the least common in construction? The fixed wing hybrid is the least common just because of cost. And people would just prefer multi-rotor on its own or a fixed wing, not a hybrid. All right.